Hello and welcome to the GCSE Chemistry tutorial for topic C7 Organic Chemistry. This tutorial is part 2 covering more organic chemistry, looking at alkenes, alcohols, carboxylic acids, addition polymers and condensation polymers. Remember this term, homologous series. So far we've looked at alkanes, we'll be looking at alkenes, alcohols and carboxylic acids. They've all got different functional groups, but they all behave in the same way as their group. Starting with alkenes, these are unsaturated hydrocarbons. So that means they only contain hydrogen and carbon, but this time they have a carbon-carbon double bond. So for example, if you look at ethene, it has a double bond here, propane's double bond is here, and butene. The general formula is CnH2n, which basically means the number of hydrogens is double the number of carbons. Alkenes burn with incomplete combustion. That means there's not enough oxygen. So as well as forming carbon dioxide and water, they also form carbon and carbon monoxide, which is a poisonous gas. You can test for alkenes by adding bromine water. Bromine water is an orange colour. You add it to the alkene and shake it lightly. If it turns colourless, it shows that an alkene is present. If it doesn't and stays orange, that means it's not an alkene. The reason this happens is when ethene reacts, or any alkene reacts with bromine, a reaction occurs, as shown here. There's other reactions of alkenes. When they react with hydrogen, it's called hydrogenation. In the presence of a catalyst and hydrogen, an alkene will turn into an alkane. Look at this example here. They'll also react with halogens, as shown with bromine water, but also here shown with chlorine, to form dichloroethane. Alkenes will also react with steam and water to form an alcohol. For example, butene and water will turn into butanol. This also requires a catalyst. What are alcohols? Alcohols are the general formula CnH2n+1 and OH, so they end in OH. Again, they follow the same pattern based on the number of carbons: methanol, ethanol, propanol and butanol. Alcohols can be made either by fermentation with yeast to make ethanol and carbon dioxide, or, as mentioned before, reacting with steam. Alcohols are flammable, they have a neutral pH and soluble in water. They're often used as solvents and fuels. When added to oxygen, they form carboxylic acids. Carboxylic acids have the functional group COOH. They react with carbonates to form salt, carbon dioxide and water. And they also dissolve in water and ionize to release hydrogen ions. The examples of carboxylic acids are below and also in this table here. Alcohol and carboxylic acids react together in the presence of a catalyst to form an ester and water. Esters have the functional group COO. As shown here, this is an example of how to form ethyl ethanoate. You pause the tutorial and attempt these questions now. Unsaturated hydrocarbons mean they contain a carbon-carbon double bond. So the carbon isn't fully saturated, it's not fully with lots of hydrogens. Instead, there's a carbon-carbon double bond. What happens if you add alkane to bromine water? Well, the bromine water would remain orange. It wouldn't go colourless because you're not adding it to an alkene. The general formula of an alcohol is CnH2n+1 OH. You can produce alcohol by fermentation or reacting an alkene with steam. Addition polymerisation. So let's remind ourselves what polymers are again. They're long-chain molecules made of monomers joined together. When monomers join together, the double bond of the alkene breaks and opens, and then other monomers join in a long chain to form a long polymer. This requires pressure and a catalyst. Whenever you write a polymer out, you always put it in brackets with the letter N next to it. So here's a polymer of ethene to become polyethene, and the polymer of chloroethene to form polychloroethene. Condensation polymerization involves monomers with different functional groups. The monomers react together to form long polymer chains and new bonds. But also, for each new bond formed, a molecule of water is lost. There's natural polymers that exist, like amino acids, proteins, DNA, and simple sugars. Try these 2 3-mark questions and pause the tutorial now. So, how do you make polyethene? Well, you need to start with ethene and you heat it with high pressure and catalyst. The double bond will break, open up, and lots of these will join together. To represent that, you put brackets around it with the letter N. So this is polyethene. The difference between addition and condensation polymerization. Addition polymerization requires one monomer with a carbon double carbon bond and one product is formed. Condensation polymerization can require 2 reactive functional groups from 2 monomers and 2 products are formed, often water as well. In summary, we've looked at alkenes, alcohols, carboxylic acids, addition polymers and condensation polymers.